All right, guys, in this lesson, we're going to be looking at data collection through two types of ways. First through surveys and then through experiments. So let's just look at data collection through surveys. And there's a couple ways that we can basically gather our data or gather our numbers through surveys. The first would be through a census, and that's a count of a complete population. So if we were to take an entire population that we're trying to study and get a response from every single one in that population, then that would technically be a census. When you see the word parameters right here, most of the time you should associate that as basically the numbers that represent a population as a whole. So when you see parameters, you think population. We can also collect data through a sample as well, and that's a count of a part of a population that attempts to draw information about the population as a whole. So we are trying to determine whether or not some behavior or something represents an entire population as a whole, and we're doing that through just collecting data from a few in that population. And so when we think about the word statistics, those are the numbers that are essentially going to represent the sample, which is in turn designed to represent the entire population. And so there are a couple ways that we can actually sample. The first is through just a simple random sample, and that's when, or an SRS, if you ever see that, the same thing. And that's when everyone in the population is given an equal chance to be selected. And you want to think kind of, if I were to put a whole bunch of names of that population in a hat and I randomly drew them, that's a simple random sample, basically, or a way that we could simple random sample. There's also stratified sampling as well, and that's when a population is divided into homogeneous groups called strata. And when we think about stratified sampling, we think about dividing high school students by class, so by freshman, sophomore, junior, and senior. Those classes would be the strata, essentially. And so individuals in a stratum have some sort of similar characteristic. In all of those strata, all of those students share the same class, basically, and so they have that similar characteristic, and that's what basically defines stratified sampling. In that same vein, we also have cluster sampling, and that's when a population is divided into heterogeneous groups called clusters. And if we want to think about this, we would think about dividing high school students by classroom, not by class, but by classroom. That's when individuals in clusters are closely related by availability. So one is basically separating students based off of their class. They have that same similar, that's a similar age. That's their defining characteristic that's essentially similar, whereas cluster sampling, they don't have that characteristic that's similar. The only characteristic that they share is that they're in the exact same location or classroom in that case. And so that's kind of the difference between stratified and cluster. Very similar, just different in that there's one that they could change. It's based off of location. That's something that can be changed fairly easy, whereas stratified is not something that can be changed fairly easy. We also have this idea of systematic sampling, and that's when a population is listed in some order and then picking every nth person in the list. If we were to list all high school students alphabetically and pick every 10th person, that would be an example of systematic sampling. And then we also have this idea of multi-stage sampling, which involves pairing more than one of these four methods together and basically combining them. Like, let's say we were to split up all of our students in our high school, and we were just looking at the freshman class. So we're just only taking the freshmen. That's the stratifying part of that. And then we are going to pick every 10th freshman to sample. And that's the systematic portion of it, is picking every 10th one. So that's an example of like a multi-stage sample in that sense. There are also characteristics of a well-designed sample, the first one being randomization, and that's to arrange individuals in order to pick them by chance method. And we can do this through quite a few ways. You can use a random digits table, a random number generator on your calculator, you can roll dice, you can draw names out of a hat. There's many ways to actually randomize, and if you're asked to describe how you would randomize, you need to make sure, especially on FRQs and things like that, that you describe, hey, I would assign all these individuals a number and then use a random digits table to decide which ones I'm actually going to sample. You would actually have to write that out and describe that as being randomization, basically, for a well-designed sample. And then we also have this idea of bias, which is something that we want to avoid. And that's if a sample does not match the population in some way. And our goal of randomization is to avoid bias. However, it's not always going to be the case. And there are multiple types of bias that we can find in surveys. The first one being a response bias, and that's when an individual in a sample gives misleading results. If they lie in some way on a survey, that could be an example of a response bias. An example of this would be their political opinion or the amount of money that they might make. Something along those lines could present a response bias. We also have the idea of a non-response bias, and that's when an individual in a sample does not respond. Either they cannot be reached or they just do not give answers. That's an example of a non-response bias. We also have convenience sampling, which is when individuals are chosen because they are easy to reach. Since there is no randomization, they may not represent an entire population. And an example of convenience sampling would be if I'm just going to call the first 10 numbers in the phone book and sample those people. Well, the only reason that that represents convenience sampling because I'm just being lazy and only picking the first 10 numbers, and those first 10 numbers, I'm trying to get their political opinion on something. Those first 10 numbers, they may all be highly Republican or highly Democratic, and I'm not going to get a whole picture of how those individuals might respond in that particular area. So that's kind of an example of convenience sampling in that sense. We also have this idea of undercoverage, and that's when an entire group of individuals is missing from the randomization process, i.e. if we're doing a survey on the internet, we would have eliminated everyone who does not have access to the internet. So that's an example of undercoverage in that sense. We also have this idea of voluntary response bias, and that's when individuals in a survey select themselves as participants. So that would be doing a survey on the internet, and then the individuals choose to respond, or they don't choose to respond. And most of the time you're going to see people with very strong opinions, and that being an example of a voluntary response bias. And so that would be, that would be what a voluntary response bias would be. And then we also have a wording of question bias, and that's when a question on a survey is designed to lead individuals to respond in a certain way. Now, it's important to note when thinking about all of these biases that it should be understood that there is considerable overlap among those classifications. For example, a non-neutral question may be said to have both a response bias and a wording bias, or one or the other. Selection bias and undercoverage bias also would go hand in hand, and voluntary response bias and non-response bias could also go hand in hand. So kind of what's being said here is that if you can, if you're asked to define the source of bias in a question, particularly like an FRQ question or something like that, and you don't know whether or not to go with response or wording, just put one of them down, and that's probably going to be okay. If you can kind of learn what one is, what response is, then most of the time you should be able to understand what wording might be, or selection and undercoverage, something along those lines. So that's really all that's kind of saying. And then this is mostly just a summary of everything that we just went over. There's really no need to go over that. So let's look at data collection through experiments now. We're done with surveys. Let's look at experiments. So experiments are when some type of treatment is done on the individuals in a sample. And you're going to have two types of groups with experiments. You're going to have a treatment group, and that's when the individuals in an experiment are receiving a treatment, and you're going to have a control group as well, and that's when individuals are receiving the same conditions as the treatment group, but they are not receiving a treatment. And then we have this idea of an observational study, and that's when there is no choice as to what individuals go into what treatment group, basically, whether they're in the treatment group or the control group. That's definitely what an observational study actually is. And so we have multiple parts to an experiment. The purpose of our experiment, first off, is to test the causation of one variable on another. And so you have two types of variables in an experiment. You have an explanatory variable, and that's the variable that is causing the change. And then you have a response variable, and that is the variable that is changing because of the explanatory variable, or because of the change, basically. Or that's essentially what we're testing, is whether or not the explanatory variable has any effect on the response variable. And then we also have vocabulary for treatments. So there are three things when you're asked about treatments in an experiment. There are three things you basically want to define. The first one is factors, and that's when there are different variables on the same individuals. The second one is levels, and that's then the factors are applied in different ways to the same individuals. And then the treatments, and those are the factor and the level that an individual receives in that particular treatment. And we'll look at an example of how to define all of that, basically. And so in this example, an AP statistics teacher asks her students who would like to participate in extra tutoring sessions. 40 responded that they would like to help, so she would like to know if duration and repetition are factors in their success. She decided to divide the students up two ways, 2 hours of tutoring versus 1 hour of tutoring, and 2 times per week versus 1 time per week. She decides to give them 40 multiple choice questions at the end of 1 month to check their progress. And so in this example, we're asked to identify the experimental units, the explanatory and response variables, and the treatments as well. So all three parts for the treatments. And so our subjects here, or our experimental units, are basically just the students who help outside of the classroom. And then we have our explanatory variable, which is actually 2 factors. That's the length of tutoring and the number of sessions that they go to. And then we also have our response variable, which is the 40 multiple choice questions, or the result, basically, of how they do on those 40 multiple choice questions, because the teacher's trying to track their progress, basically, and how they do. And then our treatments are all of this below. So again, our first part that we're looking at are our factors. So our first factor is, again, the length of tutoring. That's basically just our explanatory variables. And then our second factor is the number of sessions. And so both of those would be considered factors. Our levels are whether or not they go for 2 hours per session or 1 hour per session. And that's basically the levels of one of the length of tutoring. And then our levels for our second factor are whether they go twice or once in this case. And so our treatments end up becoming 4 separate treatments. Our first treatment is if they go to 2 sessions for 2 hours, or 1 session for 2 hours, or 2 sessions for 1 hour, or 1 session for 1 hour. And basically what we're trying to determine is which group is going to do the best, basically. And so that's essentially how you would set up an experiment and define all of that, basically, all the experimental units, explanatory and response variable, and the treatments that were actually listed as well. And so there are a few more characteristics of a well-designed experiment. First being blinding. And these are all, they don't have to be applied to every single experiment, but it's important to know what they are and how they relate to an experiment. Blinding being the participants do not know what treatment they are receiving. A double blind would be when neither the administrators of the experiment nor the participants know what treatment is being received until probably after the experiment. We also have this idea of blocking, and that's when individuals are grouped together in some way before they are randomized, either by gender, race, age, etc. It could be a multitude of other things. We also have this idea of replication, and that's can the results be repeated in a significant number of subjects? And so that definitely defines a well-designed experiment. And then we have causation, and that's trying to determine whether or not a cause and effect relationship can be established based on that experiment. And there are a couple ways where causation can't be proved. The first being is this idea of confounding variables, and those are variables that are outside of the treatment that is causing the change in the response variable. So there could be something else that's outside of the experiment that's causing the response variable to act the way that it's acting. That's not the explanatory variable. And so that's an example of how causation can't be proven. And then we have this idea of a common response as well, and that's when a variable outside of the treatment that is causing both the explanatory variable and the response variable to change. And so it's common in that it's causing both the explanatory and the response to change as well. If you're asked to set up an experiment based off of information that they give you, like in an FRQ or something along those lines, you could say something like this. So with this example, they say there is a rising trend for star college athletes to turn professional without finishing their degrees. A study is performed to assess whether reading an article about professional salaries has an impact on such decisions. Randomization can be used to split the subjects into two groups and those in one group given the article before answering questions. How can a block design be incorporated into the design of this experiment? So what they're saying is they're asking us to basically split up and block how we would essentially make this experiment. So if we're given a group of star athletes and we want to block them, what we could do is we can split them up into two ways. And it doesn't have to be underclassmen and upperclassmen, but that's one way to do it. We could say the first block includes just underclassmen and the second block includes upperclassmen. And then from there, we could randomly assign both of those to either Group 1 or Group 2, depending on whether they're upperclassmen or underclassmen. So underclassmen has a Group 1, underclassmen has a Group 2, upperclassmen has a Group 1, upperclassmen has a Group 2 as well. Group 1, in both cases, will read the article, whereas Group 2, in both cases, does not read the article. And then from there, you could compare the answers to see the difference between the response of underclassmen versus the response of the upperclassmen as well. And so, again, the subjects can be split into two blocks, underclassmen and upperclass, before using randomization to assign some to read the article before questioning. With this design, the impact of the salary article on freshmen and sophomores can be distinguished from the impact on juniors and seniors. Similarly, you can also, like I said, you don't have to split them up between underclass and upperclass. You could also split them up between men and women, or you could split them up between high GPA and low GPA, different sports, those with different majors. There are many ways that you could block that experiment appropriately. But the goal is to just understand that when you are using a block design, you are going to have to split them up in some way. And so just kind of a rehash on this experiment stuff, or data collection by experiments. Experiments involve applying a treatment to one or more groups and observing the responses. Experiments often have a treatment and a control group. Blocking is the process of dividing those subjects into representative groups by bringing certain differences into the picture. For example, blocking by gender, age, race, etc. Random assignment of subjects to the treatment group is extremely important in handling unknown and uncontrollable differences. So we use random assignment to make sure that we don't run into any bias type issues or problems. Random assignment refers to what is done with the subjects after they've been picked for a study, whereas random sampling refers to how subjects are selected for a study. Variables are said to be confounded when there is uncertainty as to which variable is causing an effect. The placebo effect refers to the fact that many people respond to any kind of perceived treatment. Blinding refers to subjects not knowing which treatments they are receiving. Double blinding refers to subjects and those evaluating their responses, or administrators of the experiment, not knowing who received which treatments. Completely randomized designs refer to experiments in which everyone has an equal chance of receiving any treatment. Randomized block designs refer to experiments in which the randomization occurs only within blocks, and randomized paired comparison designs refer to experiments in which subjects are paired and randomization is used to decide who in each pair receives what treatment.